represented by a letter because it never ends and it never repeats, so you can't write out the whole thing. So we represent the whole number by the letter E, just like we represent pi with a symbol instead of a number. When we round it to 3.14, but that's not the whole thing, right? So when you write out pi, you're saying, I want the exact number, which is going to go on forever and never end. So let's look at where E comes from. Have any of you guys ever heard of E? The number E? I'm sure you've heard of E, but not the number E, maybe. All right, so we're going to look at this formula that we did some work with in 4.1. It's the compound interest formula, compounded n times per year. So remember, compound interest is when your interest gains interest. So if you compound more often, you're going to get, like, if you compounded monthly, you get a 12th of the interest put in every month, and then that interest would gain interest. And so the more often you compound, the amount you get gets bigger and bigger, but it's going to grow at a decreasing rate. And you'll see what I mean here, hopefully, in just a second. So we're going to be doing lots of application. One application of logarithms is the magnitude of earthquakes, which is very relevant to us in Alaska. So this is another application of exponential functions, the compound interest formula. If you do not recall what all those letters represent, write those down right now. You should already have this in your notes, so if you already know it or you know where those notes are, you don't have to write it again, but if you don't know, write it down. So capital A, and you guys, when you're working through these problems, pay attention to like capital letters versus lowercase. Sometimes it won't matter, but sometimes you'll have an uppercase and a lowercase, and you got to distinguish the difference. So you want to keep it capitalized if it's capitalized. Capital A for this formula is the amount at time t in years. And again, some books will use different lettering, but it's the position where they are. So A is over there by itself. That's what it's solved for. That will be the amount at time t. Hi there.
One for each kid. They don't have it.
Oh, okay.
Run out, let me know.
Thank you. All right, so I'm going to pause this video. It's the initial amount. It's also in the same location where our initial population was when it wasn't compound interest, but just exponential growth. So initial amount, R is your interest rate, but it has to be converted to a decimal. And then N is the number of times you compound the interest in a year. And the last one there, T, is time in years. So let's look at a scenario here. Suppose that Alexi, of course she's not here. Hi Alexi, you better be watching this video. Invests $1. We're going to simplify this problem so that you can see where the number comes from. It's involved with anything that's continuously compounded, but this is going to give us the exact number. Suppose Alexi invests $1 at 100% interest rate for 1 year. Write the equation that models the situation. So the amount we have, we don't know, so that's going to be A. And I'm going to do this, we don't have a whole lot of time. So what's going in for P, the initial amount? How much did you know? $1. Do I need to write it? No. If I will, though, just for now, but I'm going to simplify it in a second. Then I have 1 plus 100%. R is 100%. What is that as a decimal? Not 1.0. Move the decimal over 2 places, you get 1. So 1 over n, and because it doesn't tell us how often it's compounded, we're going to change that. We're going to increase the number of times it gets compounded to the n times 1 because it's 1 year. If I simplify that, I get, I'm going to leave that one off, and I'm going to leave that one off. I get 1 plus 1 over n to the power of n. So let's say that she gets this, it's compounded 1 time a year. How much would she get if she starts with $1 and she gets 100% added to it? How much would she have at the end of a year? $2. Oops, this is supposed to say Alexi. Huh. Add it in here. Okay. Determine how much Alexi will have in the account at the end of the year for each value of n. So we have the amount in the account was 1 plus 1 over n to the n. So grab a calculator. When it's 1 time per year, she's going to have $2 because 100% of 1 is 1, which is what would be added. Okay, if we compound 4 times a year, n is going to be 4. Can you guys tell me what you get when you put 4 in for n? And then we're going to do 12, 100, 1,000, and 1,000,000. So you're going to put 4 in for this n. And make sure you put the parentheses where the parentheses are. So you're going to have parentheses 1 plus 1 over... Sam, what are you getting? Yeah, that's what I thought. Okay. Anybody get it?
I have
2 point, give me to the, because we're talking money. $2.44. So because it's compounded 4 times every 3 months, which is, if you divide a year into fourths, it's 3 months long. Every 3 months, she's going to get 25% of the total interest added to her account. And so then that interest gets interest. And so you get 44 or more cents than you would have gotten. And if we were talking thousands of dollars, you're going to get quite a bit more. What is it if it's compounded monthly, 12 times a year? Yeah, Ethan? 2.61. So it went up by, it went up by how much? Like 16, 17 cents? Is that? Okay, so it went from here to here, it went up 44 cents, but then it only went up by 17 cents. It's still going up, but going up slower and slower. What about when you put in 100? Karenza? 2.70. And so it went up again, but only by 9 cents this time. So it's still increasing, but slowing down the amount that it increases by. How about 1,000?
I'll be crazy for that. I got 2.71.
2.7. Okay, now it's only going up by pennies. How about 1,000,000? Karenza, do you have 1,000,000? 2.72. Somebody.
No. He didn't actually.
It's actually well, tell me what it is.
17.
He went down.
It doesn't go down. I guarantee you that. 6 zeros. Anybody got it?
2.71.
2.71. What's the next digit? 8. So it's okay. So look, it went up. If I would have gone out to the thousands place here, it's still going up, but it's only going up in the thousands place, and then it would go only up in the 10,000s place. This is approaching a number, and if I could go all the way to infinity, which is the leap that is required to go from the math we're learning to calculus. Calculus, you have to let your brain go to infinity. If it could go to infinity, we're going to get this number called E. And E is, so it's a limiting value, and it's actually the value of E, if you round it, because this was an 8 back here, we usually use 2.72. As n gets larger and larger, the amount in the account approaches 2.7182818. I don't know what the next digits are, but it looks like it's repeating 182818, but it actually goes off randomly after that initial, like, kind of looks like a pattern, but it's actually not. So the exact number is E. We usually round it and use 2.72 for like just general purposes. But you guys, when you guys are calculating, I'm going to ask you to use the button on the calculator, which if you look at your calculator, the number E is right, if you hit second and then the divided by key, you get the number E. That'll take the whole number. And so when you're doing calculations with E, which we're going to do next week, when you do calculations with E, you're going to want to use the button. There's another button, and it's right here. If you hit second And then the LN button, it'll bring you e to an exponent, which is what you're going to do more often than anything, so that's a good one to know as well. But that is the number e. So when you see e, think, oh, that's right, it's a number. You guys are probably getting used to the pi symbol, that that's a number, but e is going to be new to you for a little while until you get used to it. Okay, so anyway, that is that. Want this on here?
1, 2, 3, go.